Hello, 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 hello. Hello. So, today we start VSEPR theory. VSEPR theory. Got? It is basically theory given for deciding the shape of covalent molecules. Okay, so theory given for deciding shape of covalent molecules. Okay, this is the theory given for the how to decide. Theory given for deciding shapes of the covalent molecule of the covalent molecules. Okay, so what is the basic concepts behind it? Steric number, in short we call it Sn. Okay, steric number, in short we call it Sn, steric number. So what is the meaning of Sn? Sn is basically sum of the lone pair plus bond pair. Okay, lone pair plus bond pair. Now, how to understand what is lone pair, what is bond pair? So bond pair is shared between two atoms. Bond pair BP is shared between two atoms. Got it? So basically one electron each atom is sharing. Pair means two electron. Okay, pair means two electron. So each atom is sharing its own electron, that is one electron from each atom. So one from each become two, that become pair. So we call it bond pair. Second one is lone pair. Lone pair is on a single atom. Single atom. Basically it is unshared. What is it? It is unshared, not shared. Okay? I'll give you simple example. Suppose I take simple molecule methane, CH4, very simple molecule. carbon having outermost 4 electron. Each hydrogen need 1 electron to complete its duplet. This duplet and octet thing we learn later on in this topic only. Just wait for that. So basically carbon having 4 electron in the valence shell. These are the 4 electron in valence shell, and each hydrogen will share 1 electron to complete its duplet. So each hydrogen is sharing its 1 electron to complete its duplet. So it is a duplet for hydrogen. Each hydrogen will complete its duplet. So each hydrogen will complete its duplet. Carbon will complete its octet. Octet means 8 electron. Got it? So octet means 8 electron. If you look at the yellow circle, there is a mistake in this. So if you look at the yellow circle, this yellow circle contains 8 electrons. Got it? So we call it octet. So here, if you draw the Lewis structure, it will look like this. It is basically dot diagram. If you draw the bond line structure, it will look like this. Okay? We can count it. I am changing the color so you can see how to count. So counting will be like this. Watch carefully. 1, 2. I am counting for carbon. 1, 2, 3, 4, 5, 6, 7, 8. So it is a counting for hydrogen, carbon. So carbon octet is completed. Here you can see there is no lone pair. All the electrons are shared. So basically there are only 4 bond pairs, no lone pair. So here 4 BP, 0 LP. Got it? The number of bond pair and lone pair. 4 bond pair and 0 lone pair. Is it clear too? Okay. Now changing the page, I will take another example. Suppose I take another example of ammonia, NH3. Okay. So here first we have to decide what is the central atom. Previously I have not introduced you with the term central atom. Simple carbon, how it is sharing its electron in order to complete the octet, and how it is making bond. Okay. So here basically carbon is the central atom. We will focus the central atom thing here. What is central atom? I think the sharing thing is clear to everybody. What is the meaning of sharing and how the electrons are shared and how we count bond pair and lone pair. Next, here central atom. So nitrogen we call it central atom, Ca in short, central atom. Got it? Central atom. So what is the meaning of central atom? Generally least electronegative atom is central atom, and hydrogen can't be central atom. Got it? Hydrogen cannot be central atom. In any case, hydrogen is never a central atom. So other than hydrogen, we have to check which is least electronegative. So basically electronegativity we have done in periodic table. Okay. Still I will recall you certain values of the electronegativity. Sorry. So that you can recall all the values. So first member is hydrogen. I will change the color. First values for hydrogen, that is 2.1. Helium is inert gas. We don't have any electronegativity value for helium. Second period we can go lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Again, neon will be there, inert gas, electronegativity not defined because it cannot make bonds. So, it is second period. Now, the values will be, you can remember, start from the 4 and difference of 0.5. So, 3.5, 3.0, then 2.5. It's very simple to remember. 2.5, 2.0, 1.5 and 1.0. So, second period values are very simple. Start from 1 and increment 0.5, 0.5, 0.5. You will reach up to 4. 1, 1.5, 2, 2.5, 3.0, 3.5 and 4.0. Got it? Very simple to remember. 4.0. Most electronegative. It is the most electronegative. Most electronegative. It is most electronegative. Second most electronegative, can you tell me? The second most electronegative is oxygen, 3.5. Okay. Now we can go for third period. Sodium, okay. Here also you can remember very easily. Start from 3.0, okay. Start point 3.0. Take a difference of 0.5, so it is 2.5. Now there is a difference of 0.3, so it will start from here. 0.9, 1.2, 1. Then 0.3, 1.5, okay. Then 1.8, 1.8, 1.8, then obviously 2.1, okay. 0.3, difference of 0.3. I'll change this value properly. It is 1.5, 1.5. It is 1.2. Got it? So similarly, we can remember the values of the electronegativity. So central atom, generally least electronegative atom is central atom, and hydrogen can't be central atom. Is it clear to everybody? Here, suppose I have carbon, nitrogen, oxygen in a molecule, then we have to search for least electronegative. That will be the central atom. But generally 3 atom case, it is a very difficult thing, okay. It is useful for the 2 atom case. 3 atom case, again we have to remember few things, then only we can decide. So this rule is only applicable. Generally least electronegative atom is central atom, and hydrogen cannot be central atom in a molecule, molecule having 2 types of atoms. Understood? It cannot be applied everywhere. Blindly it cannot be followed. It is not a rule basically. It is a thumb rule based on the experience of a teacher. Okay. So it is not a rule. It is not given by anybody. Okay. So you can say it is given by teachers. That's why it is a thumb rule. General experience, common experience. Got it? Next, I will take one more example. Say I have a molecule called H2O. Okay. Previous example we have not counted the central atom and all those things. So we can do here. We can take the complete counting here. So nitrogen basically having 5 electron, 1, 2, 3, 4 and 5. Now I will use different symbol for hydrogen. Hydrogen I will use cross. Hydrogen cross for this, another hydrogen cross for this. So that we have done it already. Duplet, duplet, duplet. Now we have to go for octet. So this is the basically octet. Understood? So here you can count 1, 2, 3, 1, highlight number, don't worry, So this is basically duplet. Okay, I'll give the number 1 bond pair, 2 bond pair, 3 bond pair. So there are 1, 2, 3 bond pairs. So BP is equal to 3, and obviously you can see lone pair is 1. So bond pair is basically 3 and lone pair is equal to 1. It's equal to sign. Bond pair is equal to 3 and lone pair is equal to 1. Okay. So what is the stick number that we have learned so previously? What is stick number? Stick number is summation of the lone pair plus bond pair. So in every case, here the stick number is 4, 4 plus 0, it is 4. Second case, it is also stick number 4 thing, 3 plus 1. I will take one more example, H2O, okay. So here same, hydrogen cannot be the central atom, so there is no other choice. Oxygen must be the central atom. So oxygen is basically central atom, 1, 2, 3, 4, 5 and 6. Now you can see my smart working, right? I am doing what? Wherever I want to share, I keep only one electron, and I don't want to share, I keep a pair. Got it? So again, hydrogen, I will make a cross here. Another hydrogen, I will make a cross here. It is a duplet thing, duplet, and we can draw the octet thing. This is octet thing. Okay. So if I draw the bond line structure, it will be look like this. Oxygen, hydrogen, and these are the lone pairs. So BP basically, BP is equal to 2 and LP is equal to 2. So again it is a case of stick number 4. Understood? Now we will take some complex example, say HNO3. So there are 3 atoms, hydrogen is there, nitrogen is there, oxygen is there. So hydrogen cannot be the central atom, we can cross it, it is not central atom. So out of nitrogen and oxygen, we have to decide which one is central atom. So least electronegative, you can check. I will show you the values. These are the values. Nitrogen 3.0, oxygen 3.5. So least electronegative is nitrogen. So obviously nitrogen will be the central atom. So nitrogen will be the central atom here. Nitrogen is a central atom having 5 electron in the outermost shell. There are 3 oxygen. So basically what we do, we just join them by single bonds. Okay, hydrogen we can join by single bond, then oxygen we can join by single bond, another oxygen we can join by single bond, another oxygen we can join by single bond. Got it? All the atoms now connected. Once they are connected, we will go for the completion of the octet. So hydrogen we will go for the duplet thing. So duplet thing is done. Nitrogen octet thing is already done, 1, 2, 3, 4, 5, 6, 7, 8, right? We have to complete the octet of oxygen. So how to complete the octet of oxygen? See, in this type of arrangement, you will see that each oxygen will complete its octet like this. Okay, the good student can understand there is a problem, but those who cannot understand, that's why I have taken this example, is a very common mistake done by student. Okay, good student can easily understand that there is a mistake in the layout of the molecule. Got it? So if you go like this, then there, what will happen? The formal charge here is minus, formal charge here is minus, formal charge here is minus, formal charge here is 0, formal charge is 0. If you take summation of formal charge, it will be equal to what? Summation FC, summation formal charge. Few people, they are getting confused, what is formal charge? I will explain you. Summation formal charge is equal to minus 1, minus 1, minus 1, plus 0, plus 0, so that is equal to minus 3. It is nonsense, because on this molecule there is no formal charge. Got it? So such type of arrangement is wrong. Is it clear to everybody? we cannot do such type of arrangement. Then what is the correct method to draw such molecule? So basically it is called oxyacid. We need further information. So there are two information, additional information. One is what is formal charge and how I calculated these formal charges. I will come back again. And what is the meaning of oxyacid? So oxyacid, it is oxyacid. As the name suggests, oxygen acid. Acid means proton liberator, which liberate proton, and oxygen must be there. That's why the name given oxyacid. So basically it is oxyacid and it is monobasic. What is the meaning of monobasic? Liberate one proton. Liberate one proton. Okay. So this information if you have, then you can only draw the structure, otherwise there will be a problem. And how to get the formal charge, that is also we can decide. So basically formal charge thing is used to decide the correct layout of the molecule, correct arrangement of the atoms in a molecule, covalent molecule obviously. If it is correct, then it will follow the formal charge thing, otherwise it will not follow the formal charge thing. Okay. So this is a wrong structure, right? It is a wrong structure. Wrong. Because it is not following the formal charge thing. Okay. So by knowing this information, what is oxyacid, and it is monobasic, liberate one proton. The meaning of monobasic is liberate one proton. We can go for the correct structure. So how the correct structure will be there? So since it is a monobasic, there must be one OH bond like this. Then one oxygen is consumed here. Duplet of oxygen is completed. Then we have oxygen, one more oxygen, one more oxygen. Now we can complete the octet of nitrogen. So octet of nitrogen can be completed. Okay. Now we will go for the Lewis thing. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Show. Look at the pen. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 completed. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Got it? All atom except hydrogen. Hydrogen is duplet thing. Other atoms must have completed their octet. So they have completed their octet. Is it clear? Same time, the 5 electron of nitrogen also consumed. 1 electron consumed here, another consumed here. 1, 2, 3, 4. You will be wondered that why there is a fifth one. Okay. So there is a surprising thing in chemistry. So you may wonder that where is the fifth electron, sir? Okay. So this is only 1 electron, 2 electron, 3 and 4 that you have shown on the board. Where is the fifth one? Okay. That mystery can be resolved by using formal charge. How to get the formal charge? Formal charge is basically number of the valence electron. Okay. So number of the valence electron, I write it VE, valence electron. Then I have to minus half of the shared electron, then minus unshared electron, USE. Okay. So this formula you can remember. I will expand the terms. VE is the number of valence shell electron, electrons. SE is basically shared electron, shared electrons. Sorry, the good student can easily understand, or the awakened student, I will not call it good student every time. Every student is a good student. Awaken, those who are waking up properly, paying proper attention, they can easily understand why is half is there. Because sharing means half. One is your, one is mine. That's why it is half. Got it? And unshared is not sharing. So full contribution, unshared electron. So USE is basically unshared electron. Unshared electrons. Got it? Unshared electrons. So let me finish it quickly. So nitrogen, here will be formal charge +1, here formal charge 0, here formal charge -1, you can calculate, here formal charge 0. There is no need to calculate formal charge on hydrogen. Hydrogen formal charge is always 0 because it can have only duplet thing. Got it? So now if you follow the summation formal charge rule, that will be equal to +1 -1 is equal to 0, and on the whole molecule there is no charge. So our layout is correct. Okay. So now we can count the bond pair and lone pair thing on center atom. Thank you very much.